This time we're going to start working on the main internal frame for the DO droid. And to do that, we're going to need quite a few pieces. This is the actual center frame for the droid. That's where everything's going to attach. Then we have the front and rear panels for that, and these actually are to hold these bearings in place. And we have a couple of those. I believe those are 6805 bearings. We have the two printed gears that will go on the motor. We have a gear for the servo that we'll be using to connect the neck of the droid. Our two motors. The servo base, we're going to have also about 5 pounds of lead shot that will go down into the bottom part of the frame to give it some balance. We're going to need our epoxy, the neck servo, and various hardware to put it all together. So what we're going to start with is mounting the motors to the main frame, and before I do that, I'm thinking I will solder a couple of leads to each motor so that we don't have to fuss with that later. Let's bring back the pieces for the next step, and we will go from there. To mount the motors, we're going to use some of the M3 10mm screws that we have here. I've got the wires all soldered on, and I think that's really all we need to do to prep those for the moment. Okay, I've had a little change of plans here, and I can always switch back if it looks like this isn't going to work. But I originally was going to use these printed gears that had the captive nuts that attached to the motor shaft here, but I'm actually going to try something a little different. I have these couplers that I could use with a different type of printed gear, and this allows me maybe to get a little bit better bite with the included screws onto the motor shaft. So I'm going to go ahead and put some of these together. I'll be using just a 10mm screw through here and nuts to hold that on. So let me do that really quick to a couple of these, and we'll go from there. That's what we have. And the second one. So one of the things that I know is that this is going to have a little side-to-side play and need to be adjusted to correctly line up with the ring gear that's in the outside wheel. But we'll play around with this a little bit and kind of see how we can get it to line up. I think that looks pretty good. Just for fun, I'm going to secure it and maybe hook up some power just to spin the motor and make sure that the gears move freely. Okay, I seem to have a good lock on the gears there. Now for the scary part, we'll hook up some power and see if this moves correctly. Okay, scary part. That moves nicely. So you can see the green part of this is the actual wheel assembly. And we haven't done any lubrication of the gear, anything like that. But everything's running nice and smooth, so I think that gear is in the proper position on the motor shaft. So we'll flip this thing over and do the other side, although I think I'll take this side off. We're not going to need this on there anymore, and in fact it'll be in the way. But that was a successful little test, I would say. All right, so flip to the other side, basically do the same thing, get an idea, have an idea about where the alignment will be this time. So I think that'll be a little easier. And back these out. The other thing that's nice about these, as opposed to the 3D printed ones, is I don't think we're going to get a lot of wobble. If the thing is set up off center, or the gear tends to get off center. I think we're going to be in pretty good shape. So that's another thing that I like about using these. I think I'm lined up about the same, but we're going to grab the other wheel and do the same thing we did just a minute ago. Also, it's just a good chance to test the motor, make sure that all is well there. I think we have pretty good alignment there too. I think that's going to work really well. And this, with these motors, this is going to have lots of power. So it'll be nice to get the motor controller in there and kind of test it out a little bit. And the Arduino as well, so that we can get the radio control hooked up to that and test out just kind of the wheel part rolling around. Make sure everything's good there before we're going to proceed on to the head and all of that. But I'm going to take this apart for now, and we'll continue working on the interior frame. We're going to start putting in the servo that's going to control the neck arm. So there's going to be an arm that sticks out the side that moves the neck and head assembly for the droid. And we need to get the servo installed for that. But before we can do that, we have to do a couple of things. One, there is a kind of a servo mount. It's not really so much a mount as it just kind of elevates the position for the servo, so it's kind of like a servo base, and really that just presses down in there. So that's the first step to getting the servo in and ready. All right, while I'm waiting for the glue to cure on the servo gear, let's go ahead and get the servo installed. So I'm using a MG996R servo for this. This will be controlling the head bar, this guy right here. And we talked about putting this plate in the bottom. That is basically just to provide a nice stable platform for the servo. And you'll notice that there's sort of a round depression in that servo mounting base. That's where we want to be sure that we're lining up the part of the servo that's going to be spinning the gear, the shaft there. So that'll just go in through here, sit nice and flat in there, and then we'll use the included servo screws, which are going to self-tap into the plastic, and then there are screwdriver holes here so that we can actually get into that area. So I may turn it around, and we'll figure out how we're going to turn it around to get that done. But let me grab a longer screwdriver, and we'll go from there. Okay, so a couple of hours have gone by and the epoxy Gorilla Glue is dry inside of the servo gear. So we have the horn and the servo gear glued together. Now I'm going to go ahead and attach that onto the servo. There we go. I think we have that attached correctly. Next, we're going to go ahead and put the captive nuts into the frame where we're going to be screwing on and attaching different parts to the chassis. Some of the stuff might fit tight enough to stay. Other parts of it may need a little bit of hot glue or other assistance to stay in place. So we're going to kind of feel that out as we go. One of the things that I know are these bottom ones definitely do not stay in without assistance, and so I think that's where we'll start. So these are M3 nuts that we're going to be placing in there. Okay, I think we have all of those in. I like that some of them will stay in without hot glue. That's a lot nicer and a lot cleaner. Not that anyone's going to see this, but having hot glue kind of splashed all over the place is not really what I like. Okay, for the next part, we're going to need the front and back side panels and the 26805 bearings, and we'll also need a couple of the M4 nuts. All right, first off, there are some spots in these plates for the nuts to insert into. Okay, I actually kind of prefer those to fit tight as opposed to having to use hot glue. Now I'm going to go ahead and just press fit the bearing into the side, and I think that will hopefully just press fairly easily, and it does. There we go. See if that's the case on both sides. Okay, this one may require just a little bit of sanding for that to fit in. Okay, well, we have that in. So we've got both sides done. Okay, now we're going to have to work with this piece. This is the main bar, and it will fit in here between the two bearings. So a little bit of prep that we have to do, because we need these holes that are in the end, the holes in the end need to line up with these, which are for some more M3 nuts, but the hole doesn't go clear through. And that was just so when they're printed, we get a nice square hole there. And so I'm just going to punch through with the drill bit, try to clean that up just a wee bit. And I may need to get in there with a X-Acto knife to clear out the rest of the flash from that nut hole. And I'm just using just a drill bit. I think it's about a 1/8 drill bit. Just this, whatever was more or less the same diameter as the hole. So, and we'll just see if we can scrape out or clean out a little bit of the debris in there. Okay, the next thing we need to do is to start with the front insert, and you can tell that because it's the one that has a little cutout in it. So, I believe that will fit down in like that. So we'll need a couple of 10mm M4 bolts for this. And we already have the nuts for those captive in here. So what we should do, there's a slot down at the bottom, that slot in this piece. So that slot will hold the bottom half. And then from the back, we're going to have to tighten up these bolts. All right, I think we've got that set in there. So there's the front side. And then I believe we need to get this main bar fixed into there. All right, so this should go through the bearing center and onto the gear. All right, so we have that down there. The gear is engaged on the servo side. And then all we have to do is to slide this over and attach to the other side. And that will go over the other side. And then we have our head bar mechanism in place. All we have to do is just insert the last 2 screws here. All right, we're making some progress here. It's starting to look like something. Okay, the next thing we have to do is, this is going to need some weight, especially with the amount of power that the wheels are going to have, and we don't want this thing just every time it takes off basically rocking or kind of pulling a wheelie. So for the ballast, we're going to actually be using some lead shot and filling that up into some of the areas here in the frame. Now these 2 spots are for batteries, and so we won't be putting them in there, but we will be loading it down into kind of these empty or vacant holes here. They go down into just a big space. It also connects up through here as well. So we're going to fill that with some of the lead shot, and then I'll probably stuff some bubble wrap and tape over the openings where we've got the lead. Okay, there's our approximately 5 pounds of lead shot. And to get this in here, I think I'm going to maybe use a funnel to try to pass this down through there. And we're going to have to make sure that we get things shifted around right to make sure that it's somewhat balanced before we pack it in there. So here we go. Rocking it back and forth to try to find a balance point here to where it's not tipping forward or backwards. And I'll do a little side to side. Now that it's in there, what we need to do is to pack material in here so that this doesn't shift around. So I'm going to probably do a combination of foam and bubble wrap in here. Just kind of looking through my supplies and seeing what I have and try to keep that lead in place. Well, with the lead shot in there, we've got our ballast, and this is starting to become a heavy little beast. And I think we've got enough foam padding secured in there, and some of this will smash down when we put the top cover on. But I think we've got, for the most part, we've got it compacted in there pretty well and balanced. It's going to be, you know, there might be a little, you hear a little shifting in there. But I think for the most part, I think we're in pretty good shape. I can probably push more foam in here into these openings. I'll do that right before I'm ready to put the top cover on. When I affix this top cover and anchor that down, that will hold in any of the foam that may be wanting to push its way out. So basically what we have here now is a completed frame as far as the motors and the servo mechanism for the head bar. All of that is pretty much done. And as we go forward, it's going to be time to get the Arduino programmed up, start making some wire looms and getting the motor controller in and getting some of the programming dialed in, and then we can kind of test a little bit to see if this is going to work correctly. Because one of the things it does have is an accelerometer that should try to balance it out if it starts shifting one way or the other. It should hold it up and down. So I think that's a good place to stop for this video, and we will pick up with more soon.